Okay, what do we have for 0? Who can help me? Faith, what'd you get? 0, 0 is correct. You type in 10 times the sine of 3 times 0. 10 times the sine of 3 times 30, 10 times the sine of 3 times 45, and so on. What'd you say? Yours was in radian? I might have used. You should be in degree, because these are degrees. You're taking the sine of 3 and then multiplying it by 360. It should be 10 times the sine. You're taking the sine of the whole thing. It's 3 times 360, all in parentheses.
Oh, okay.
JR, what'd you get for 30? You're taking the sine of 3 theta. That whole thing is in parentheses. Because theta is your degrees. You have to take the sine of some number of degrees. Like this. 10 times the sine of 3 times whatever. Did you get 10 for 30? Carolina, what did you get for 45? 7. 60, Andrew? 90, Maggie? 120, Lydia? Did you do the first quadrant? Oh. Sarah, what did you get for 120? 135. Mike? Hit the 1. Hit the 1. Yep. Clear your screen. Hit a 1. Hit a 0. Hit the sign. Hit 3 times 135. And then hit enter and tell me what it says. Positive? 150, Lydia? Uh-huh. 180, Allie? You know, okay, I'll wait for you. Okay. 210, Val? Tori, 225? 240, Madeline? Yep, that's probably right. And 270, 10. Is it 10? Okay. All right, so this, look at how many times this has a radius of 0. A lot. Every time you have a radius of 0, you return to the origin. That's why, look at your picture. It looks like a rose petal, like a flower, and it comes back to the origin a boatload of times. Now, Andrew mentioned changing the scale, which at first I didn't know what he was talking about, but as soon as I looked at the size of these radii, I knew what he was talking about. We don't have 10 circles. So every circle we're going to have to count as, like, like 2. That'll be a radius of 2, 4, 6, 8, 10. That's not bad, right? So if you have a radius of 5, just go halfway between. Everything will be pretty much halfway, even 7.1. Again, it's just a rough estimate. What's that? Okay, so this is going to be the first time we see that happen. So start at 0, 0. And then do your 30 and then 10. 2, 4, 6, 8, 10. 45 is going to be 7, so 2, 4, 6, 8. So 7 would be halfway in between those two. And again, make sure you're connecting these in the order that you plot them. So this is going to kind of circulate out to that further point. And then it starts wrapping back in until you get to 60, 0. Now you're back to the origin. Mind you, you're back to the origin before you've reached the 60-degree angle, so do not let your pedal go over the 60-degree marker. Does that make sense? Keep your pedal narrow enough that it gets back to the origin before it ever gets to that 60-degree line. Is that fair? If you make your pedal go over that, you will have inadvertently plotted something like 70 degrees with something out there, which it won't be. So we're back to the origin. Then 90, which is this ray, goes to negative 10, so that pops us backwards, 2, 4, 6, 8, 10. So the question is, and think about the pattern that we left off with. We looped around. How are we going to connect this one with this one? With a straight line, or are we going to swipe through the third quadrant, or are we going to swipe through the fourth quadrant? Okay? If you don't know, there's a big gap there. Just out of curiosity, if I were to plug in a 70-degree angle, what would I get? 10 times the sine of 3 times 70 gives me negative 5. So a 70-ish with a negative 5 would put me in what quadrant? A 70-degree angle, which is a first quadrant angle, but with a negative radius is going to back me up into which quadrant? The third. So we definitely want to go through. To go from 0 to negative 10 is a very big jump. You have to know that that's going to like carve into the third quadrant in the between part. And same thing here, 120 immediately brings us back to 0. Again, I mean, if you just follow the pattern and the more you get used to these, it's very circular, so this is going to go through the fourth quadrant to get back. But if you want to just check, you could plug in like 110, and you're going to get a negative number, which means if you're plugging in a second quadrant angle with a negative number, you have to be swirling through your fourth quadrant. Does that make sense? Second quadrant angle, but with a negative radius will pop you over to the fourth. So you're coming back to the origin again right here, and then you're going to be still in the second quadrant, but now with positive. So 135 and 7.1, 2, 4, 6, 8. 7.1 might as well be 7 on our graph. 150 and 10. And then 180 and 0 brings you back to the origin, so we have to go out to those and back to the origin. So we're done with half of our chart. And when you move on to 210, which is here, and go to negative 10, that's the same point that we already drew. So it actually, this whole second half of the graph are different representations of the same points we already did. So it really just goes over itself a second time. Does that make sense? Okay? Not all of them will do that. I'm trying to remember the patterns. Oh, right here. If n is odd, and look at your format for this, n is odd, and so we have n loops. N was 3, we have 3 loops. They repeated twice, though. It was the same 3 loops 2 times. So it was 6 loops, but it appears to be 3. Follow? If n is even, like if that was 10 times sine of the, like 4n, we would actually have 8 loops. 1, 2, 3, 4, 5, 6, 7. That's a funny one. So that's probably just a 7n type picture. 7 loops, 7n. No, you don't, because you're just going to go over itself twice. So no, you don't have to. And then you have a lemniscate, which we're just going to bypass because it'll be more of the same graphing of points. This one is just kind of interesting. And there is? Let me see it. That's not that interesting. Oh, okay, so we're going to use, he already did the table, so what he's finding is you plug in 0, 30, 45, until you get to 60, you're fine. But the cosine of 2 times 60 gives you a negative number, times 9 makes it a negative number, and then you're taking the square root of both sides because you have to actually solve for r in this one. And so they don't exist. So let's see if we graph all of those. 0, 3, 32.1, 45, 0, so you've done that. We really have nothing to do here, and we pick back up at 135, 0, which is where we are anyway. Yep. 150, which is here, goes to 2.1. No, that's but you're getting this top first. Yeah, why? But it will all work out. So 180 is 3. So that goes there. And then when you come back around, you're just going to come back around, and that's going to be what you see. You just skip those points. Your homework.
No.
Yeah. Sorry. Thank you. I'm glad you did that because then we could cover that in a solid 2 seconds. There's 3, 4, 5, 6. Leave one for Maggie. Here's you 3. Oh no.
Miss Ray, big sponge out of course.
Oh, no, that's at like an event.
PreCalc.
It was fun. Here, that's for your back row. No, he has a Jeep Wrangler.
Oh yeah?
And he has a dune buggy.
Yeah, I had so many of those.
Both courtesy of my neighbors because I would never buy him one.
Oh, really?
Yeah.
Why not?
Well, to be honest, I'd like to just get rid of him as is because as soon as he got them, he stopped riding his bike. And he was like, he was really good. And he has no interest in he was riding a bike around when he was like 1.5. Now he has no interest in taking the training wheels off. He just doesn't even care. But he would so easily do it. But he wants to ride those. So this technology thing is killing me.
Yeah, but they've had those around for so long.
I know.